Hello, Sugar Plums. Welcome to another video. So this lesson is about assignment number 28 on solving quadratics using the quadratic formula. This is everybody's favorite, the quadratic formula. Now, before we get to it, there are some steps we have to look at, okay? So guys, first and foremost, number one, okay, you have to set the quadratic equation equal to 0. Isolate the quadratic, get everything on one side. Number two, you gotta list the values of A, B, and C. Now remember, when you have a quadratic equation, ax squared plus bx plus c equals 0, the values A, B, and C, guys, look at them. They're right there. The number in front of x squared is A. The number in front of x is B. And then the constant term is C. Now, be very careful. If B or C is missing, okay, notice I didn't say A because you can be missing the A. Fill in 0. You got to fill in 0 if either B or C is missing. Now, guys, listen, the quadratic formula will solve all quadratics. So if you can't complete the square, do the quadratic formula. If you cannot factor to save your life, do the quadratic formula. And if you cannot do the squared property, what are you going to do? Of course, you're going to do the quadratic formula. The quadratic formula, guys, solves every single quadratic equation. Okay. Now, I was at step number 2. Step number 3, you're going to substitute A, B, and C into the quadratic formula. And the quadratic formula is x is equal to the opposite of b, or you could say negative b, plus or minus the square root of b squared minus 4 times the a value times the c value, and all of this gets divided by 2 times a. Now I put parentheses around a and c because when you guys are working on the formula, you have to make sure you be careful with those negatives, okay? Step 4. Next, you need to simplify. What am I writing here? Shazam, okay? Now we're gonna simplify. When you are simplifying, guys, be careful, simplify this. Some things to say about this. When it comes to simplifying, guys, with the quadratic formula, sometimes you'll find a negative inside the radical. Of course, that's going to be kind of imaginary. So if you had something like this, -9, this would become 3i. If you have the square root of 8, that needs to be simplified. When you simplify this, it's going to become 2 radical 2. If you have the square root of 16, you got to simplify that. That becomes 4. So make sure you're simplifying well. And furthermore, sometimes you have to reduce the fraction because this is a big old fraction, people. All right? Now, some of you may be wondering, why do students like the quadratic formula so much? Here's why they like the quadratic formula so much. It's just a formula. All they're doing is plugging in values, substituting in values, guys, and then working it out. So the formula is right there. All they do is plug in the numbers and simplify everything out. That's why it's so easy. Okay, we're not done. There's more. All right, the part inside the square root or under the square root, right there, guys. This is called the discriminant. It's just like what it sounds, guys. It discriminates the answers. So the discriminant is b squared minus the 4 times a times c. So just the part under or inside the quadratic formula, that is called the discriminant. This one tells you the number and types of roots you will find for the quadratic. Okay, so it helps to clarify the number of roots and the types of roots you will find for a quadratic. Now, there are 3 cases for the discriminant. If you calculate the discriminant, it becomes a value that's greater than 0, as in it's positive. This means that you will end up with 2 real roots. Now, if you calculate the discriminant, you get 0, then this is going to lead to 1 real root. Now, next, the third case is where the discriminant is less than 0. And if the discriminant is less than 0, then you're going to have a negative value. And that negative value is saying you're going to end up with 2 imaginary or complex roots for the quadratic, guys. So depending on what kind of a value you get for the discriminant, that determines the outcome of the quadratic equation in terms of the solutions. Now you notice there's only 3 possible outcomes. 2 real roots, 1 real root, and 2 imaginary or complex roots. So having said that, I'm going to mention graphing a little bit. When you graph a quadratic, guys, the graph of a quadratic is called a parabola. Either it'll open up or it'll open down. We'll see these later, but right now I want to mention the solutions. If you have a quadratic that has 2 real roots, when you graph it, the graph might look something like this. Let me use a different color. You might end up with a graph that looks something like this. So that the graph intersects the x-axis twice. Wherever that graph intersects the x-axis, it represents a solution. So if it's got 2 real roots or 2 real solutions, the graph will intersect the x-axis twice. And so wherever the graph intersects the x-axis, that's a solution. Now, case number 2 is where the quadratic has 1 real root. If the quadratic has 1 real root and you were to go ahead and graph it, the graph might look something like this. Let me grab a different color. You might see a graph that looks like this. As in the graph is intersecting, in this case it's not really crossing, but it is touching the x-axis at one point. So wherever that graph intersects, touches the x-axis, this would represent that 1 real root. And then of course the third case is where you have a quadratic that has 2 imaginary or complex roots. Now, if they're imaginary or complex, that means that you can't see them. So therefore, when you graph this, guys, the graph will never intersect the x-axis. Never intersect the x-axis. Why? Because the roots are imaginary. How are you going to graph with those imaginary solutions, okay? So it will never intersect the x-axis when you have 2 imaginary or complex solutions, all right? So just a little preview of what the graphing is going to look like. Now, what I'm going to do is go through some of the questions in assignment number 28, starting with problem number 1. Now, guys, remember the quadratic formula solves every single quadratic. By the way, there are other methods that are very efficient, like factoring. Some of these are factorable. So if I were you, I would check to see if it's factorable first. Like this one right here, it says use the quadratic formula, but you can actually factor this, okay? As in, what are 2 numbers that multiply to give you 2 and add to give you -3? Can you find those 2 numbers? Of course, and -1 and -2. And then set each one equal to 0, set each factor equal to 0 and solve. What number -1 makes it 0? 1. What number -2 makes it 0? 2. There's your answers. Or you could use the quadratic formula. First, since the quadratic is already equal to 0, we need to find the value of a. A is the number in front of x squared, in front of the square term. So that's 1. This is your B value, and this is your C value. So A is 1, B is -3, and C is equal to 2. So you go into the formula, -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. Substitute everything in there. So x is equal to the opposite of the b, so it becomes a positive, plus or minus the square root of b. Notice I'm plugging it inside a set of parentheses, squared, minus 4 times A, which is 1, times C, which is 2. All of this gets divided by 2 times 1. Now you want to grab your calculator, guys, and do the discriminant. Do the part under the square root. Now, 3 squared gives you 9. And then 4 times 1 times 2 is 8. So you subtract them and you get 1. Okay? So now, 2 times 1 in the denominator is 2. So you're going to end up with 2 equations. So you're going to get x equals to 3 plus or minus 1 over 2. So here you have a compound solution. But you need to break this up into 2 exact solutions. I'm going to erase this so I can go to the top. X is equal to 3 plus or minus 1 over 2. So there's essentially 2 equations here, guys. One of them is x equals to the sum, 3 plus 1 divided by 2. 4 divided by 2, that gives you 2. Remember, we got these answers already. And then the difference, x equals to 3 minus 1 over 2. And 3 minus 1 is 2. 2 divided by 2 gives you 1. There's your other solution. And just like that, you're done. All right, guys. Now, this next one, number 2, I've got negative y is equal to 4y squared minus 3. Again, they want us to use the quadratic formula. The equation has real number solutions. Find the solutions. Now, I am going to take the negative first. The quadratic is not equal to 0. I want to set it equal to 0, guys. Since I like working with a positive square term, I am going to take the negative y and move it over. So this will become 4y squared plus y. That negative y from the left side goes to the right side and becomes a positive. And then this will equal to 0. Now, I am going to list the value of A, B, and C. Remember, A is the number in front of the square term. B is the number in front of the linear term. So B in this case will be 1, and C is the constant. Now, we're going to go ahead and plug them into the formula, guys, okay? So let's go into the formula. X equals to the opposite of B plus or minus the square root of b squared minus 4 times A times C, and all of this gets divided by 2 times A. A was 4. Be careful with that. So now we're going to go ahead and work out the discriminant. 1 squared is 1. 4 times 4 is 16. 16 times negative 3. Actually, it's a negative 4 times 4 times negative 3. So that's going to give you 48. And then 2 times 4 is 8. You add the 1 in the 48, so you get 49. Take the square root of the 49, so you get x equals to negative 1 plus or minus 7 over 8. And remember, this represents 2 solutions. X equals to the sum, negative 1 plus 7 over 8, which gives you 6 over 8, but reduces to 3 over 4. And then the other one is the difference, negative 1 minus 7 over 8. So you get negative 8 divided by positive 8, which gives you negative 1. So there's your answers, guys. See, the quadratic formula is so easy. Okay, now guys, this one right here, it is factorable. So I'm just gonna factor this one. X squared minus 6x plus 9 equals to 0. So I'm just gonna factor it. 2 numbers that multiply to give me 9 and add to give me a negative 6. That'll be negative 3 and negative 3. If you will notice, they're repeated factors, so I can rewrite this as a binomial squared. So what number minus 3 mixes 0? Positive 3. And that's it. Okay, let me see here. Do I want to do, yeah, why not? Okay, x squared plus 2x plus 26 equals 0. Is this one factorable? No, it's not factorable. You cannot find two numbers that multiply to give you 26 and add to give you 2. Impossible. Is this a good candidate for completing the square? Yes. If some of you want to complete the square, complete the square. Now, I'm going to use the quadratic formula because it says to use the quadratic formula in the directions. You don't have to. So when I substitute everything in, I get the opposite of b. B is positive, so it becomes a negative. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Grab your calculator, plug the discriminant into your calculator, let the calculator do it for you. 2 squared is 4. Now, 4 times 26, that's going to be 104. So 4 minus 104 gives you negative 100. You could have plugged all that into your calculator. All right. Ooh, we have a negative under the radical, guys. That means we're going to end up with an imaginary value. So we get 10i over 2. Why do we have an I here? Because there's a negative under the radical. Whenever you encounter a negative under the radical, it becomes an imaginary unit. Now, the next question is, do we leave it like this? No, you got to simplify this one. So what you will notice is that the negative 2, the 10i, and the 2, they're all divisible by 2. So we're going to divide all of them by 2. So this becomes 1. This becomes 5. This becomes 1. So this will simplify to negative 1 plus or minus 5i. Another thing you could have done is negative 2 divided by 2. So that's your negative 1. And then plus or minus 10i divided by 2. That would give you your 5. Or 5i. Same thing. All right, guys, this next one's easy. Okay, they give you x squared equals to 15. You got to find a, b, and c. First, move the 15 over so it becomes a negative 15. You have your x squared term, so a is 1. You don't have an x term, so b is 0. And c is negative 15. That's it. That was 5. Number 6. Oh, 6 is too easy. I'll let you guys do that one. 7. Oh, they want you to find the discriminant. So based on the discriminant, they want you to find out how many solutions and what type of solutions. The equation, this is number 7, by the way. This is number 7. So x squared minus 13 equals to 0. A is 1, B is 0 because the x term is missing. C is negative 13. So you go into the discriminant formula, b squared minus 4 times a times c. B is 0, a is 1, and then times negative 13. You didn't have to do this part right here. So you multiply all of this together, you get 52 because it's a positive value. That means d is greater than 0. It's positive, so you're going to have 2 real roots, 2 real solutions. And that's it. All right, the next one is also a discriminant problem. You are given 2x squared minus 8x is equal to negative 8. And this is number 8, guys. And so the first step is to move that negative 8 over. So it becomes a positive 8. Find the value of A, which is 2, value of B, which is negative 8, value of C, which is 8. So now you're going to go into the discriminant formula, b squared minus 4 times a times c. Now, if you want to, you can actually say d is equal to that, okay? You don't have to. So we're going to plug in these values, so we get negative 8 squared minus 4 times 2 times 8. So essentially, you grab your calculator, just plug it into the calculator, and you will get the answer. Negative 8 squared is 64. 4 times 2 is 8. 8 times 8 is 64. So when we add all this up, we're, in this case, subtracted, we get 0. So because D is equal to 0, this means we have one real root. And that's it. All right, guys. Number 9 is another discriminant question. 2x equals to negative 2x squared plus 4. So we're going to take the 2x, move it over. We're going to set the quadratic equal to 0 first. So we get negative 2x squared minus 2x plus 4. Normally, if I was actually doing the quadratic formula, ooh, what was that? Okay, something happened to my pen here, guys. Hold on. I'm trying to fix my pen here. Something happened to it. Okay, I don't know what happened, but something happened to it, everybody. Anyways, I'm repairing it, okay? I think it will work. Hold on a second. Let me try and get this all together. Okay, I think it's good now. Oh, okay. Anyways, normally, guys, if I was solving for the using the quadratic formula, I would not leave this negative here because I don't like working with negative leading coefficients, okay? So because I'm just finding the discriminant, b squared minus 4 times a times c, I'm gonna work with it anyways, okay? But normally, I wouldn't. All right, so the a value here is -2. The b value is also a -2. And the c value is 4, okay? So I'm just gonna go into the formula and substitute everything in here and just work it out. Type it into my calculator and let the calculator do it, guys. So this gives me 4. -4 times -2 is 8. 8 times 4 is 32. I add them together, I get 36. And that's the value of the discriminant. So because it's positive, that means I'm going to have 2 real roots, or 2 real solutions. Same thing. All right, the next one is another discriminant problem. I'll let you guys figure that one out. 11 is a discriminant problem as well. You guys can figure it out. Now we're on to some word problems, guys. Okay, so listen carefully. This one is problem number 12. It says a ball is thrown downward from the top of a 190-foot building with an initial velocity of 23 feet per second. The height of the ball, h, after t seconds is given by the equation h is equal to -16t squared minus 23t plus 190. Okay. Oh, let me just erase that and write it over again. That's looking like a hot mess over here. Plus 190. There we go. How long after the ball is thrown will it strike the ground? When this ball hits the ground, guys, what will be the height of the ball? The height will be 0 when the ball hits the ground. So in other words, at what time will the height be 0? When will, or what value of t will make this equation equal out to 0? And they want you to round this to the nearest 10th, guys. So a is equal to -16. B is -23. C is 190. Now you grab your calculator. Actually, just plug everything into the formula first. The opposite of b is 33, plus or minus the square root of -33 squared minus 4 times a, which is -16, times 190, and all of this gets divided by 2 times a, which is negative 16. All right, so on my calculator, guys, I am going to do negative 33 squared. Put that negative 33 in parentheses, okay? And I'm going to do minus 4 times negative 16 times 190, okay? So I plugged all that into the calculator. So I get 13,249 inside the square root. And all of this will be divided by negative 32 because 2 times negative 16 is negative 32. Now, I am going to take the square root of the 13,249. And I get, hold on a second, 115. Okay, I'm just going to leave it there. And I'm going to divide it by negative 132. Now remember, this represents 2 equations, guys. So one of the answers will be 33 plus 115 divided by negative 32. And you know what this is going to turn out to because you're going to take a positive divided by a negative. So this is just going to be a negative. So this is not going to work out, guys. It will not. Why? Because time is supposed to be a positive value, not a negative value. However, on the other hand, we're going to do 33 minus 115 over negative 32 divided by negative 32. That will work. 33 minus 115 divided by negative 32 gives me, remember we have to round to the nearest tenth, so this one gives me 2.6. So it's going to take approximately 2.6 seconds for this object to travel 190 feet and hit the ground. Okay, this is not a difficult question, it's just tedious. All right, guys, number 13 is easy. So I'm going to move on to number 14. 14, it seems like they just want you to factor this one. So here's the problem. It's a 4th degree expression, 4th power, okay? Minus 20z squared plus 64. Now, for this one right here, guys, they want us to factor it because it's a 4th degree trinomial. We're going to split up the z to the 4th into z squared times z squared. We want 2 numbers that multiply to give us 64 and add to give us a negative 20. That'll be a negative 16 and a negative 4. But we're not done. There's more to this problem. This is a difference of squares. This is also a difference of squares. So we're going to factor that into 2 binomials, okay? So z minus 4, z plus 4, and then for the second one, z minus 2, z plus 2. So this is the complete answer for this problem. That's just a review of factoring, guys. Ooh, this is another one that is a review of material we've covered in the past. 2 over x plus 1 over 4 is equal to 3 over x. You got to find the LCD to solve this equation. The LCD for this one is going to be 4x. So you're going to multiply every single term by 4x. If you take 4x and multiply it by the first term, the x's will cancel out. So you'll be left with 2 times 4. For the second term, the 4's will cancel out. So you'll be left with 1 times x. I'm writing it out so you guys can see where it's coming from. But I really don't need to write 1 times x. I know that's x. For the last fraction, guys, if I take 3 over x, I multiply it by 4x, the x's will cancel out, leaving you with 3 times 4. So I have 8 plus x is equal to 12. Subtract the 8 from both sides, so it looks like x is equal to 4. And that's it. Now, let's see here. Number 16 is easy. You're just finding the values of a, b, and c. 17 is the same thing, a, b, and c. 18, guys, last problem is another word problem. A waterfall has a height of 1,400 feet, a pebble is thrown upward from the top of the falls with an initial velocity of 12 feet per second. The height h of the pebble after t seconds is given by the equation h is equal to negative 16t squared plus 12t plus, that's supposed to be 12, 1,400. And so, how long after the pebble is thrown will it hit the ground? This is very similar to one of the previous word problems we did, guys. Again, when an object hits the ground, the height goes to 0. So your job is to find the value of t that would make this equal out to, ooh, Shazam, that's a plus sign here, 0. Okay, so we can use the quadratic formula, but I want to see if I can factor this one right here. Let me see here. You know what? Let's see. Can we at least reduce the equation? Yeah, let's reduce it. I can divide everything by -4. Let's reduce it and see what happens. I mean, I could go straight into quadratic formula, but I'm being lazy right now. 4t squared minus 3t is equal to, oops, that's a minus 350. You don't have to do this part, okay? You can just go from the original problem and just go into the quadratic formula. So they want us to round this to 1 decimal place. So the a value is 4, the b value is -3, the c value is -350. We did not have to reduce it, guys. I just like working with smaller numbers. That's all. You could have just done this from the original problem. So now, formula, opposite of b, +3, plus or minus the square root of b squared minus 4 times a times c, and all of this gets divided by 2 times a. So grab your calculator, put the discriminant into the calculator. You're going to do -3 squared. Make sure you put that -3 inside a set of parentheses. Minus 4 times 4 times -350. So we get 5609. And then you want to take the square root of the 5609. All of this is over 8. The square root of 5609 turns out to be, hold on a second, 74.89. All of this goes over 8. Now, guys, once again, because I'm working with time, it cannot be a negative value. It needs to be a positive value. So I want to make sure I grab the part of the equation that's going to produce a positive value. And the part that's going to produce the positive value is the sum. So I'm erasing some of this, okay? Just erasing that so I can have space to do this. Okay. So the part that I want is the x equals to 3 plus 74.89 over 8. That is what's going to produce the positive value for time. And so I want to make sure I only focus on that. I really don't need the rest of it. And so x will equal to, round its nearest 1 decimal place, 9.7. So it's going to take just about 9.7. Okay, slightly under 10 seconds for you to get that ball to hit the ground. Oh, it's a pebble. It's not even a ball. It's a pebble. For the pebble to hit the ground, 9.7 seconds, okay? All right, guys, so that is the end of assignment number 28. Hopefully you learned something and you were able to use this video to complete your assignment. And I will see you on the next video. Have a good one, Sugar Plums.